Hello everyone, this is the third video of the playlist CUDA C. Before we start programming, I want to tell you some CUDA C programming concepts and some technical terms I'm going to use in this series. First of all, I want to tell you that .cu extension is used for saving CUDA programs. CUDA Toolkit enables Visual Studio to understand that .cu files are for NVCC. NVCC stands for NVIDIA CUDA C compiler. I'll explain that later. CUDA file contains both CUDA C and regular C or C++ code, but the .cu extension tells Visual Studio to pass the program from NVCC. CUDA.h header file is included to invoke the CUDA API functions from CUDA runtime library. Kernel. The main CUDA C functions, simply those functions which are executed on the GPU, are known as kernel. Global. It is a function qualifier. If you put global before a function, it means it's a kernel and should be called from CPU and run on GPU. How do we define a kernel? Let me tell you the definition. Global void some kernel. In the bracket we pass arguments, but a kernel cannot have variable number of arguments. For invoking a kernel, we use triple chevron, in which we pass number of blocks and number of threads per block. For example, when we call some kernel 2, 5 within triple chevron, it would be launched in 2 blocks, each of them with 5 threads. Thread. It is a single executive part that run kernels on GPU. Block. Collection of threads is called as block. Grid. Collection of blocks is known as grid. Each thread got its private memory, and each thread block has shared memory, which is visible to all threads of the block, and each thread can communicate to each other within the block. In this heterogeneous programming model, CUDA threads execute on GPU that operates as a coprocessor to the host. This model assumes that both host and device maintain their own separate memories, and this assumption involves memory allocation and deallocation on GPU, and data transfer from host to device as well as from device to host. Kernels cannot access system memory, so first we allocate the memory on GPU using CUDA malloc functions. This function is used for the allocation of memory for the device pointer on the GPU's global memory. This function contains two parameters. One is device pointer and size in bytes of the device pointer. Host and device both cannot see each other's RAM, so we need to copy data from host to device and device to host. And for this, we use CUDA memcpy. This function copies data from host to device or device to host. This function contains 4 arguments: destination pointer, source pointer, size in bytes of pointers, and enumeration direction. Usually we use two types of enumeration direction: CUDA memcpy host to device and CUDA memcpy device to host. We use CUDA memcpy host to device when we want to copy data from host to device, and vice versa. CUDA free. This function is used for free up the global memory of GPU. CUDA free contains only one parameter, that is device pointer. Okay, now one question is for you: how does CPU thread differs from GPU thread? Please comment your answers below, because knowledge is free. So please, if you like my work, then like, share and subscribe. Thanks for watching.